We start off example 14, looking at some review here, so I'll give you a chance. You should either memorize these or look back at our 4.1 notes. If you're an AP test taker, you should know these by heart. So I'll encourage you to pause and give it a try. So let's see how you did. If you don't have them memorized yet, this is our list. I went back to the 4.1 notes, this little chart of integration. These are the big ones. Maybe someday I'll come up with a great way to remember which is which, but right now I don't have that. So we integrate according to, all right, we got the square root of 1 over x squared. That turns out to be sine inverse of x plus c. We've got now, so there's the one with, well, no, never mind. I was going to try to come up with a way, but then we got 1 over, this turns out to be tangent inverse of x plus c. And then the last one turns out to be secant inverse of absolute x plus c. So a couple of notes, a couple of reminders real quick before we leave this. Could I have written this as arc tangent of x plus c? Would that be the same thing? The answer is yes. Those are the same thing. Could I rewrite this as, let's say, cotangent, right? Isn't tangent inverse and cotangent the same thing? Is this the same? That answer is no. Those are not the same thing. Remember that tangent inverse is not the same as cotangent. Cotangent is the reciprocal, not the inverse of tangent. It's the reciprocal. So here we are again for those AP test takers. Good luck. These are something to put on that little list of functions to have memorized. But today's notes are pretty brutal because we're going to try to, even knowing how to look them up, it's still pretty rough. So let's take a look, though. That doesn't scare us. So evaluate the following, compare and contrast. I think he's going to talk about, or the idea that he means by that is where this x is, what happens when we have that extra x in there and when we don't. So I always like to start off by trying to rewrite this so I can see if I can use a u/du. So let's think, how would you rewrite this integral? So I would rewrite this as the quantity of 4 minus x squared to the negative 1/2 dx. That root was on the bottom, so when I brought it up, I would try this with the u/du first. So my u would be the inside function, and then my du would be the derivative of that, which is negative 2x dx. And right away we run into a problem. We don't have the x. I can generate the negative 2, but I can't generate a variable. So we're stuck already. So this is not going to be a u/du type of a move. So it's got to be something else, and that's where all this nastiness of these crazy inverse trig integrals come from. So which format are we looking at here? So you've got a constant, then the function under a root. You've got the constant and the function not under a root. And then the last one is a constant and a function under a root with another function. I said that wrong. This one is the function minus the constant with the function again out front. So as I look at this one, I've got the root of a constant minus a function, so that's my arc sine. So I want to think about, okay, who does A have to be if I have a 4 there? So I'm going to start writing myself little notes. A has to be equal to 2, and U has to be equal to X. And we don't have to worry about any of that because when we derive X, we would just get 1, which is what we have on the top. So we can go ahead and just use the arc sine formula. So this would be the arc sine of U, which for us is X, over A for us, which is 2. Don't forget your plus C, your constant. All right, let's try the next one. So I'm going to try a rewrite first. See if this is something that I can handle without trying to use one of these formulas up above. So when I rewrite this, I get x times the quantity 4 minus x squared to the negative 1/2 dx. Now when I do a u du, we already did the u du over here, I needed an x and I didn't have it. Now we have that x. I don't have to use one of these formulas. I can use a simple u substitution. So u would be equal to my inside function. Du would be its derivative, negative 2x dx. I'm going to do this one by pattern recognition. So let's see, what do I need? I need a negative. I don't have it. Sorry, any constants? No constants. I need a negative, so I need to correct the negative that I need to put. Oh, I need a negative 2. So I need the negative and the 2, so I need to correct that with a negative 1/2 times. So this now, the u has gone in, the dx has gone into the x, the dx, the negative 2 that I created with this correction, all becomes my du. This is what I called u. So u to the negative 1/2 integrated would be u, which for us is 4 minus x squared, to the add 1 would be 1/2, divided by 1/2, which would be 2 over 1, plus c. We notice our 1/2 and our 2, they're going to cancel out, so I would just have negative square root of 4 minus x squared plus c. All right, look at the next one. Here we go again. I'm going to try to rewrite to see if I can find myself a shortcut. So this is the same as the integral of 2 plus 9x squared to the negative 1, because it was on the bottom, dx. When I u-du this, my du is going to have a 18x. I don't have an x to work with. I could do the 18, but not the x. So that means this is going to be one of these up above. So there's the one with the root, the one without the root, and the one with the root and an extra variable in there. So this one, we're looking at something without a root, so that's going to fall into this case. I want to first identify who is who. So my a, so if a needs to be squared and I've got a 2 there, what does a have to be? It's got to be root 2. And then what squared? U is what gets squared to make 9x squared, so that would have to be 3x. Now that means according to the chain rule, I'm going to have a du that is 3dx. So I'm going to have to compensate for that. I'm going to have to make sure that I generate that up above. So let's take a look. So do we need to any sorry, I think I said a constant. I think I wanted to say a correction. So do we have 3dx? We do not. So I need the 3. I'm going to generate the correction. 1/3 times. And this formula is 1 over a. Well, what is our a? Is root 2. So 1/3 times 1 over root 2. Arctangent of u, 3x, over a, which was root 2. And then don't forget your plus c. Now I'm going to clean this up. I'm going to do a super cleanup. You don't have to. If you don't want to, you could stop at this spot. If this was a free response, I definitely would and move on to the next thing. But I'm going to times this by root 2 over root 2. So I would get root 2 over, that would then become a 2. So I would get a 6. Arctangent, I would times this by root 2 as well. So I would have 3x root 2 over 2 plus c. I think that's as cleaned up as we could possibly get it. Decide if you can use u-du or if you're stuck with using one of those nasty formulas. So I've got the integral of x times the quantity, 2 plus 9x squared, to the negative 1 dx. If I do a u du, yeah, I'm liking a u du. Because when if this is my u, the du will be 18x. I've got an x to work with, so I don't need to use the formula or one of those trig forms up above. So u would be 2 plus 9x squared. Du would be, that's gone, that's a constant. That becomes 18x dx. All right, so let's look back up here. What do I need? Constants, none. I need to generate an 18, so I need to correct that 18. So that became that 18 that I made, the x and the dx, and so this would really be u to the negative 1. Well, u to the negative 1, the integral of that is natural log of our something, of our u, plus the constant. So that'd be the natural log of 2 plus 9x squared over 18 plus c. So today's notes are actually, or this section of notes are pretty brutal. I mean, this is some real knockdown, nasty algebra that we're going to have to do as we're going through. It's not really all that fun calculus. So this section, to be honest, too, you're not going to see a ton of it. I mean, I can't get my kids to get a 5 if I don't show them problems that might occur on the test. So the more you see of this, the easier the other stuff will be, because these nasty ones, you'll get some practice with the easy stuff. These nasty ones, the easy stuff you don't even think about, like the UDU part of this, we're not even talking about anymore, right? We're just doing it. And so the nastiness that's around the UDU is what you really need to be able to do. All right, so see if we can, says that they're going to be a bit high maintenance. So let's see if we can come up with a way to reorganize this into one of these up above. So can we UDU this? I need if that's going to be my U, so the DU would be a 2x. I've got an x, but it's an x on the bottom, so I'll never be able to do this with u's and du's. So I'm going to go right to trying to find a formula. So this has a function with a root. So this is a root, this is no root, and then this is a root with a function. And what I mean by function is the u's. The u's stand for a function, the a stands for a constant. All right, so let's try to do a rewrite down here. Let's get rid of anything that is constant. So the 9/5, I'm going to take that out right away. 9/5 times. All right, so if you look up above, yeah, this is the arc secant move. So I want to go back down there and try to define who is u and who is a. So actually, I'm not going to be happy with that. Let's go here. So u is equal to x, and a is equal to what? 4. So now let's try this again. So I'm going to take out my 9/5 times, okay, what's the derivative of u? Was dx, so I don't need to create anything. I've already got a dx. We've already got our x on everything's good there, so I don't need to mess around with any of this. So I can just go back up here and I can follow this crazy formula. So it's 9/5 times 1 over a, we said a was 4, times the arc secant of absolute u, which we said u was x, over a, which is 4 for us, and then what can't you forget? Plus c. Not too bad to clean this up. I would expect you to be able to clean this up. Let's try 9/5. How about 9/20? Arc secant of, could I rewrite this as absolute 1/4 x plus c? Would that give me the same result? Yeah, because 1/4 is positive. So you can put that 1/4 in and out. The x wouldn't be able to jump in and out of that absolute value. That wouldn't be legal. So is this okay? Sure. Sure, you can do that if you want to. I don't know why you would want to, but you could do that if you want to, if it looks nicer. But they'll do that on the multiple choice section, so you got to be ready for it. All right, let's take a look at the next one. Can I u to u this? The derivative of this is my inside function, would be 8x. I like that, except the x is on the bottom again. So, oh, no, wait a minute. No, yeah, I'm in trouble, right? U would be 4x squared minus 9, which means du would be 8x dx. I've got an x, but that x is on the bottom. So, nope, this doesn't work again. So let's try this using our formulas from up above. I want to first try to identify who is who. So, well, which one are we going to use? Yeah, it's the same one, right? It's going to be secant again because we've got the function with the root. So I'm going to identify this as my u. So what squared would have to make 2x? So that would have to be 2x. This is my a. A would have to be 3 when I square it. And now don't forget, you need to make sure that you're checking for that correction if you don't have those pieces that you need. So you need to make the du, you need a 2 dx. Well, we've got the dx, but we don't have the 2. So we're going to generate the 2. Oh, actually, this is an interesting one. Look. So I need to generate a 2, but I also need this has to be worth what? That has to be worth 2x, because that's what the formula is function, then function squared. So we've defined our function, our u, to be 2x. So this x needs to be a 2x. And then to generate the du, I need a 2 in front of the dx as well. So if I need a 2 to appear there, and I need a 2 to apply there, it actually kind of works out that it's kind of a 2 for 1. So I'm going to rewrite this as the integral of 2 dx over 2x root 4x squared minus 9. So that's kind of slick. So that's going to allow me to put this together as my du. This is going to become my du. This is going to become my u. This is going to become u. And then this is still going to be a squared. You know what I mean? All right. So let's plug and chug. No corrections, right? Our corrections canceled each other out. So I needed a 2 on the top. I needed a 2 on the bottom. So I multiplied the whole thing by 2 over 2. So that's going to leave us with 1 over. We said our a value was 3. Our secant of absolute u for us is 2x over a, which was 3, plus c. I told you, all kinds of nasty. Let's try the next one. Who would be my inside function? Let's see. So definitely inside would be e to the 2x minus 1. Du would be, so what's the derivative of e to the 2x? Is e to the 2x. Then you got to do the change. So it'd be 2 e to the 2x. Derivative of 1 is 0. So we'd get this. So we need an e to the 2x, which we don't have that here. So that, my instinct is that's dead meat. We're going to have to look for one of these formulas up above. But that even sounds a little bit, that doesn't work out, because look at this, is a is the constant and u is the function. So in this case, my function is e to the 2x minus 1. Now I can't just factor out a negative. Remember, if you take out a negative, you can spin those things around. But where would that negative occur? Where would that negative be? It'd be underneath the square root. So we would have a big problem there. So we can't do that. This one doesn't have any roots, so we know that it's not arctangent. Well, must be this one then. At least this one has the functions in the right spot. So it's u squared minus 1. So let's try to generate this down here. So I'm going to start off by highlighting what I think u is going to be. So I think u is going to be, okay, so I need to rewrite this as something squared. Actually, I'm just going to rewrite this as e to the x squared. So now who is u in this case? U is e to the x. And then a, what squared makes 1? That's 1. So now I've got this idea of what u is supposed to be. U is supposed to be e to the x, but I'm also supposed to have an e to the x here. I'm supposed to have another e to the x here. That failed us. Well, if I wanted, okay, so I wanted to have an e to the x out front, but so if I want to use this rule, whatever this function is getting squared, which for us is e to the x, needs to have another e to the x there. So basically, I want there to be an e to the x here. Well, don't forget, if this is our u, we have to still follow the u du stuff. So what's the derivative of e to the x? That's e to the x dx. So for me to be able to, I would also need to have an e to the x on the top here. Hey, actually, kind of like what we did here. You're allowed to multiply the top and the bottom of a function by the same thing, and you would be consistent. I mean, think about this when we, like try to add rational functions where you got like a denominator that says x plus 2 and the other denominator is x plus 3. We multiply them by each other's denominator to try to get a common denominator. So I'm going to rewrite this now. I'm going to rewrite the whole thing and see if it looks a little bit better. So this would be the integral of e to the x dx over e to the x square root e to the 2x, no, e to the x squared minus 1 squared. So this says e to the x squared. I really don't like how I wrote that. E to the x. E to the x squared. So now we can follow the formula where the formula is the u. So we would end up with 1 over a. Well, a is 1. Arc secant of absolute u. So for us, absolute u would be e to the x over a, which was 1, plus c. So arc, the 1 over 1 is 1. Arc secant of, what do we know about e to the any number? E to there's that whoosh, it's always positive, so we don't even need it, plus c. Pretty slick. Pretty slick. Now, would this be something I would expect you to be able to do on a test? Probably not. Would the AP expect to be able to do this on the test? Probably on one, maybe. But I could see this on the homework for sure, and I could see this maybe on the group portion. All right, let's keep going here. I'm going to pause for a sec. Okay, so more nastiness going on here. So we try to look at this thing. We try to do our UDUs first. See if we can just UDU it, save ourselves some time. So we get u would be the inside function. And maybe we should rewrite it first. So this would be the integral of x plus 2. Actually, you try to rewrite it. Pause. Try to rewrite it on your own. Then 4 minus x squared to the negative 1/2 dx. So if I try to u du this, my u would be my inside function. My du would be negative 2x dx. All right, well, I've got an x, but the problem is I don't just have x. I've got x plus 2. So there's no way that I can amend this just to get rid of this minus 2. Even if I subtracted 2 from the end, that subtract 2 would not be able to be performed until I did this multiplication, and we can't do this multiplication. So this whole method fails us. But there's a nice little trick here. If you'll notice, sometimes it's easier to actually break this thing apart. So remember, anytime you have two things over one term, I know this feels like it's bigger than one thing, but it's not. It's just the square root of one term. We can split this up. So I'm going to split this into the integral of x over 4 minus x squared underneath dx plus the integral of 2 over square root of 4 minus x squared dx. Now look, yeah, my question as a student would have been, how am I supposed to see that? By practice. By practice. If you're not doing all the homework sets, if you're not going into just watching me do a couple of examples every day in class, you'll never get there. You'll never be able to do it on your own. So you have to take that step of practicing. I was the same way. I looked at this. I said, I didn't know how to do it. So I had to learn how to do it, and then I had to do more practice on it. So now I'm starting to recognize these moves over time. But it's not going to happen by magic. Watching me do a couple of examples isn't going to cut it. So there's my soapbox speech of the day. So let's see if we can u-du this stuff. I'm going to try to u-du this first part. My u would be 4 minus x squared. That's the inside piece. My du would be negative 2x dx. Life is good. I don't have the negative 2, but I definitely have the x. So that's enough for me to work with. So let's see. Maybe it's better to rewrite this whole thing. This is the integral of x times 4 minus x squared to the negative 1/2 dx. So now when I integrate this, what do I need? Do I have any constants? No. Do I have any corrections? Yes. I've got the x. What would be a good color here? I've got the x. Check. Check. I've got the dx. Check. Check. I need a negative 2, so I'm going to magically put a negative 2 here. But all I need to do is just show that is correct it with a negative 1/2 times by, now my u is 4 minus, so this is going to become u to the negative 1/2. So the integral of u to the negative 1/2 is u to the 1/2 divided by 1/2. So that's going to look like for us u 4 minus x squared to the 1/2 divided by 1/2, which means flip and multiply. Now I should put a plus c here, or I might as well, plus c. Plus, now let's do this other derivative. Now right away I know my u is going to be my next integral. I look, my u is going to be the same. I'm going to get the same du, but I don't have an x to work with, so that means it's one of these functions. Let's see if we can remember which one. So this is the one that has a square root, but doesn't have the function again out front. It goes constant, I think this is sine. Let me look at my notes. Yeah, it's arc sine. So let's try to define who is A. A is 2. Who is u? X. So who is du? Is dx. So that's easy. We don't have to do any corrections. We do have a constant that we're going to have to factor out. This 2 is going to have to go out front. So 2. I wish I would have done this in orange because that's for the whole problem. I change that to an orange plus. 2 times, so this is the formula for arc sine. And it's arc sine of A arcsine of u over a. So arcsine of u, we said u was x. We said a was 2 plus some other constant. I'm going to call it d. So now that we want to clean this up and actually get the whole answer, we're going to have, so those negatives are going to cancel. This is the square root of 4 minus x squared plus 2 arcsine of x over 2 plus big C. What happened to big D? They just got combined, right? This is a constant, this is a constant, so when I add those constants together, you're going to get some other constant. That's why when I was first doing this, I said you didn't really need to write this, and you don't. You can write it at the end if you want to. 2 of the 3 integrals you can do. Evaluate the 2 that you can do and understand why you cannot do the third one. So I like to do rewrites. I like to try to rewrite and see if I can UDU it to save myself some time. Well, maybe not time, but memorizing. So I can take out the 3. That's just a constant. This is going to be the integral of x cubed times the quantity of 5 minus x to the 4th. It's a square root that was on the bottom, so that's negative 1/2 dx. So let's try our UDUs here. So my u would be the inside, 5 minus x to the 4th. My du then would be negative 3x cubed dx. Oh, I like that. Right, I don't have the negative 3, but I can, I've got the 3. We got the negative. I just need to generate the negative, but I've got the x cubed, so I can UDU this bad boy. All right, so let's UDU it. I will, I'm going to write this one up the long way. I'm not going to do figure out or pattern recognition. So 3 times the integral. Okay, I need, oh crap, that was a waste of time. I'm going to put that 3 back inside, whatever. Okay, I'm going to leave it out. So I need to generate a negative 3 in front of the x cubed. So I've got the 3 out front. I can put a negative 3 in there as long as I divide by, okay, that's my correction. So now the negative 3 that I put here, which gets canceled out there, but what I put there rolls in with that dx to make our du, and then I have u to the negative 1/2 du, which is something that I can integrate. So this ends up being negative 1 times, I don't like the way I wrote that, negative 1 times u to the add 1 would be 1/2 divide by plus c, which then would equal negative, wait a minute. Oh my gosh. Ugh. Hopefully you corrected my, did you find my mistake? I got to go way back and fix it. What's the derivative of negative x to the 4th? It's not this. Du would be negative 4x to the 3rd dx. Sorry if you just watched 2 minutes of the video with me having the wrong derivative there. So that 3 that's out front, I'm going to leave that out there. I need to generate a negative 4, so I'm going to divide by a negative 4. Multiplied by, so this, and then the negative 4 that I generated became my du. So my function is really u to the negative 1/2, or my something to the negative 1/2. So our something was 5 minus x to the 4th to the 1/2 divided by 1/2 plus c. which I can then now start to clean up. Negative 3/2. I'm going to just leave it in parentheses. Ugh. Boy, not my most impressive work so far. All right, let's try the next one. So that's my inside function again. And so when I du it, I know I'm going to have a cubed, and I don't have a cubed. So this can't be a u du. Let's see if we can generate our a's and u's. So a would be root 5. And then what would u be? Oh, yeah. What squared would make x to the 4th? X squared squared. But then if u is x squared, my du would be 2x dx. And I don't have a 2x. I got an x squared. And so this one's dead meat. We can't go any further. It's not one of our formulas. There's nothing that we can do. I don't think it's, yeah, we don't have any formulas with an x squared on the top. So game over, man. Game over. So that means this last one we've got to be able to do. Let's see if we can do it with a UDU first. To tell, I'm going to do a rewrite. So this is the integral of 3x times, if you haven't done a rewrite, try to rewrite this on your own. Pause. 5 minus x to the 4th to the negative 1/2 dx. And right away I know I'm in trouble because my u would be 5 minus x to the 4th, and my du would be negative x cubed. And if that's cubed, game over, man. Game over. So this part's out. That didn't work. So what are our other options? So that means we're going to have to do this with one of the formulas on the front. So which formula do we have? Is there a formula that doesn't have an x on the bottom? So we don't have an x on the bottom. Yeah, there is, right? And then it's constant minus. So I think it's this one again. Let's try to set up who a and u must be. So I'm going to rewrite this. I feel like I killed it. So this is the integral of 3x over 5 minus x to the 4th square rooted dx. So who would a be? A b? Who would a be? So a would equal root 5. What would u have to be? So what squared would make u to the 4th? That would be x squared. So that means du, oh, this is going to work out nice, 2x dx, right? That means that I need to have a 2x. Well, I've got an x. I mean, I don't have the 2, but that's a constant. I can work with that. All right, we're in good shape. So let's try to do this by pattern recognition. Do we have any constants here? The 3 is a constant. Multiplied by, do we have any corrections? I'm going to actually change to blue. Do we have any corrections? I've got the x, I've got the dx, but I need a 2. So to correct that, I need a 1/2 times by, and then this is the formula where we had the root with constant minus function. So that's arc sine of u over a. So arc sine of u, which would be x squared, over a, which would be root 5 plus c. How would I clean this up? I would leave this as 3 over 2 arc sine of x squared root 5 over 5 plus c. That's how I would clean it up. I don't know if they would. If this is free response, don't clean it up. I bet you they'd clean it up similar to that. All right, let's plow through these last couple ones. These are extra nasty too. They don't start off too bad. So I'm looking at this guy. I'm trying to think of, can I do a UDU? Well, no, because the derivative of this is the only thing I could pick for as a u. And so the derivative of that would be 2x plus 6, and I don't have an x to work with. So does your math voice think of anything else when you see this? I hope it does. It's screaming at me. Even before I watched the video, I knew. What does your math voice say? Factor. That factors into x plus 3, or x plus 3 squared. Now do I have an inside function? Yep. Now when I do the du, I just get 1 dx, right? So du equals dx, so that 3 is just a constant that I'm not going to have to sweat. So let's do a rewrite here. I'm going to do this doing the long way. So my constant is 3. The integral of, this is u, but it was on the bottom, so that becomes u to the negative 2 du, because du and dx are interchangeable. This should be a 2. Now we integrate, which means we add 1 to the exponent, and then divide by that new exponent. Don't forget your plus c. And then we can put our u back in there. It's going to be on the bottom. That's going to be negative. So 3 over x plus 3. I don't know why I used parentheses. Plus c. I didn't need parentheses around the bottom there. So as we move on to the next one, it gets a little sneakier because this is not factorable, right? You factor 10 makes 5 and 2 and 10 and 1, and neither of those are going to make a 6. So you kind of run out of room. You could also go for the quadratic formula, but I mean, that's going to have roots, and that solves this. It doesn't factor it. The quadratic formula finds solutions, not roots. Well, there's another way to factor this, and it's a move called completing the square. And it looks something like this. You're going to take x squared, you're going to take plus 6, and then you're going to create a blank. You push the plus 10 out of the way, and then you need to undo the blank. Now, I hope that sounds familiar. What do we do with the 6 to figure out what it busts into? This is where we take this and we cut it in half. So divide by 2, and then we square it to the power of 2. So 6 cut in half is 3. 3 squared is 9. And then whatever I put in that blank, I got to put in that blank. So now when I rewrite this, I'm going to go with a different color so that you can tell the difference. I've got the integral of 3 over, so this is now x squared plus 6x plus 9, which we already know factors into x plus 3 quantities squared. And then 10 take away 9 is plus 1. Dx. Now who's our inside function? So our inside function, u equals x plus 3. du equals dx. That's a good sign. That means I don't have any corrections. Do we have any constants? Yeah, we have the constant of 3. The integral of, this is 1 over, and this became our u, so that's u squared plus 1 dx. Now, if you're looking at that saying, now what? My math voice says that too when I first look at it, but I'm getting better because I'm doing more and more of these type of problems. I'm getting better at recognizing that that's probably one of those trig rules. So let's look back. So it's something squared plus with no root. Yeah, we're in good shape. Now, look, this one has the constant before the function, but for us, I mean, its addition is commutative, so we can just flip it around. So this is going to end up being the arctangent rule. So 1 over a arctangent of u over a plus c. All right, so our constant out front is 3 times 1 over a. A is what's getting squared to make this, so that's 1. Arctangent of u, well, let's go back up here. We defined u as x plus 3 over a, which was 1. Don't forget your constant. So if we were to clean this up, this would be 3 arctangent of x plus 3 plus c. Okay, let's have you try this one. So it's the same idea, except you have to complete the square with a slightly different value. Now, wait, this does factor. This makes x plus 4x plus 2, but that's not going to help us because we still can't do a u-du on it. So we can't break it apart. So try to complete the square and then unpause. Pause it and then come back after you've completed the square. So I'm going to complete the square again. CTS, little capital C, little t, capital S. So that's going to be x squared plus 6x plus blank plus 8 minus blank. Cut it in half and square it, so that's a 9. That's a 9. So my equation I can rewrite, I'm going to bump the 3 out right now. 3 integrate 1 over. That becomes x plus 3 quantity squared. 8 take away 9 is minus 1. Don't forget your dx. Now I can do a u-du. I can do a rewrite. So I've got now 3 integrate 1 over u squared minus 1. Du and dx are the same. So I can just, so I can sub out dx and put in a du. This has got to be one of those formulas. So this is function squared minus 1. And we are in trouble. Because this one's got a root and that one's got a root. So they're out. This is squared plus 1. That's out. So this is 1. Unfortunately, you cannot finish. Nope. Sorry. Okay, if you're watching these videos and going through, you might want to do some homework each time if you can't get all the way through the notes. Don't save the homework until the very end. Good luck.